There once was a massive proponent of using the laws of exponents. His name was Volel, he taught really well, and he's got all these videos to show it. Hello, my friends, welcome to class 3 of Unit 6. I would say thank you for listening to my little limerick, but really, it should be you thanking me for blessing your ears with that true lyrical masterpiece. If you like what you heard, I am available by Venmo and Cash App because Lord knows that a teacher's salary ain't it. From last time, we talked and discovered the laws of exponents. Take 30 seconds, remind me, look back at your notes. What are some of those properties that in theory govern how any exponential expression should behave? Go. All right, let's write them down one more time, this time with feeling. So, if I take some number, we'll call it a, and I raise it to a power of 1 over n, I know that that n in the denominator, my fraction, is going to become the index of a radical. I also know if I take any number and raise it to the power of 0, I always get 1. I also know that if I take any number and raise it to a negative exponent, that is asking me to find the reciprocal of the positive exponent, right? Where a positive would give me repeated multiplication, this guy gives me repeated division. Next up, when we were together, we saw that if we took two things with the same base and multiplied them together, their exponents, m and n, would add together. By the same logic, if we took those two things with the same base and divided one by the other, here their powers, the opposite of division is multiplication, the opposite of addition, they would subtract. For our sixth law, we said if I take something raised to an exponent, and then I raise that thing to the exponent, here the powers, m and n, multiply together, which we write as m times n, or more simply, m invisible multiplication, n. Last but not least, our last two go hand in hand. We saw if we take a product, we'll call it a times b, and we raise that product to an exponent, it is the same thing as raising each of the factors to the exponent individually, and then multiplying together. Same thing if I were to do some division. If I had a quotient, a over b, and I raised that to some exponent, it's the same thing as raising the numerator and the denominator to that exponent separately. Okay, that's great. But why bother learning these laws? Who cares? Well, our goal, of course, is to use them to do something. The name of the game here is to simplify. So our goal is to take any expressions that we see containing exponents and try our best to get it into what we'll call simplest form. Using what you know about the laws of exponents, take these 5 here. I want to see how I can fully simplify, do everything that I can with my exponents for each of these 5. Take 2 minutes, pause the video, use what you know, and see what you get. Go ahead. And stop. X to the 7th times x to the 8th. Well, I know that if I multiply two things with the same base, their exponents add. So this becomes x to the power of 7 plus 8, which gives me x to the 15th power as my final answer. I have y to the 4th over y to the 6th. Well, here when I divide two things with the same base, the exponents subtract. So this becomes y to the power of 4 minus 6, which is y to the power of negative 2. But I know how to simplify y to the power of negative 2. The negative is asking me to take the reciprocal of y to the positive 2. So 1 over y squared is my final answer. 2a to the power of 3. We know that this is really telling us to take each of the factors 2 and a and raise each one to the exponent separately. So I have 2 to the 3rd, and I can simplify 2 to the 3rd, right? That's 8, and then I have that a to the 3rd left over. So 8a to the 3rd is my final answer. Number 4 is z to the 5th raised to the power of negative 4. When I raise an exponent to an exponent, I know that I multiply my powers together. So this becomes z to the power of 5 times negative 4. 5 times negative 4 gives me negative 20. And if I have z to the power of negative 20, that negative sign is telling me that I actually want the reciprocal of z to the positive 20. So 1 over z to the 20th is my final answer. And last but not least for number 5, I've got negative 3 over c squared. Well, here I've got a quotient being raised to an exponent. I know that that is the same thing as taking the numerator of negative 3 and the denominator of c and squaring each one individually. Now, c squared, that's already good in the denominator, but negative 3 squared means negative 3 times negative 3. So positive 9 over c squared should be my final answer. Great! Now that we've got the fundamentals in theory down, let's up the ante a little bit and see if we can simplify some stuff like this. We'll do number 1 together, and then I'll set you loose on number 2. 21, v to the 0, w to the negative 4th. My advice to you, when we're solving these problems, our superpower as mathematicians, as always, lies in the ability to make things look the way we want it to look. What might be a valuable strategy that I could use here to make this look the way I want it to look, to make the process of simplifying feel a little bit more intuitive? Take 30 seconds, take a risk, take a chance. What do you think I might want to do to make this more obvious how to simplify? Go. And stop. My advice, wherever possible, it can never hurt to show too much work. The way that I'm going to show too much work here is by breaking this down into chunks. Just like my peanut butter, I like my exponents chunky. What I mean by chunking it is as follows. 21, v to the 0, w to the negative 4th. There's an invisible operation in between all of those. What operation is that? 5, 4, 3, 2, 1. There is invisible multiplication connecting the 21 to the v to the 0 and the v to the 0 to the w to the negative 4. So I'm going to make the invisible visible. I'm going to make this look the way I want it to look. Now I know how to simplify a little bit more easily. Well, 21, there's nothing I can do with that. But v to the power of 0, anything to the power of 0 is 1. And w to the power of negative 4, well, that's 1 over w to the 4th, the reciprocal of the positive exponent. And from here, all I need to do is simplify. I have 21 times 1, which is just 21. And then I have 1 over w to the 4th. Well, to make it really obvious how this is going to combine, remember 21 is really 21 over 1. And if I multiply those fractions together, numerator times numerator gives me 21. Denominator times denominator gives me w to the 4th. So there is my final answer. Let's try it for number 2. Take 30 seconds, pause the video, see how far you get, and then come back. Let's go. All right, I've got 3 to the 8th, r to the 0, and t to the negative 7. Again, I'm going to chunk it. I'm going to break it down into pieces and simplify each piece individually. 3 to the 8th, there's nothing I can do with that. But r to the power of 0, any number to the power of 0 is 1. T to the power of negative 7 really means 1 over t to the 7th. From here, I can simplify. Well, 3/8 times 1, anything times 1 is itself, so this is just 3/8. And then I have 1 over t to the 7th. Again, numerator times denominator, or numerator times numerator gives me 3. Denominator times denominator gives me 8t to the 7th. There you go. There's your final answer. Nice. Let's try some more. A little bit more challenging, but not so much so. Let's take number 1 together, and then we'll do number 2 and 3 on our own. For number 1, I have u to the power of negative 5 times u to the power of 13 all over u to the 9th. If I'm thinking about the order that I might want to do these operations, hint, hint, wink, wink, nudge, nudge, I can speak words. What might my strategy be here? Take 30 seconds, pause the video, take a risk, take a chance, make an idea. Go. All right, let's do it. U to the power of negative 5 times u to the 13. You may remember that a fraction bar is a grouping symbol. So maybe I'll think about simplifying the numerator first and then worrying about how that denominator factors in. In the numerator, I have u to the power of negative 5 times u to the power of 13. When I multiply two things with the same base, you may remember that their exponents add. So this becomes u to the power of negative 5 plus 13 over that u to the 9th. Well, u to the power of negative 5 plus 13, negative 5 plus 13 is 8. So this is u to the 8th over u to the 9th. And now I have some division. When I divide two things with the same base, their exponents subtract. So this is u to the power of 8 minus 9. 8 minus 9 is equal to negative 1. And if I have a negative exponent, I know that I'm really being asked to find the reciprocal of the positive version of the exponent. So 1 over u to the first, or 1 over u more simply, is my final answer. Try number 2 and number 3 on your own, and then come back and debrief. Let's do it. And stop. Number 2, order of operations. Fraction bar is a grouping symbol. Let's simplify the numerator first. We'll simplify the denominator next, and then we'll figure out our division. K to the 13th times k to the negative 5th. Again, this tells me multiplication. I'm going to add the powers of 13 and negative 5. And then k to the 0 times k to the 2nd, right? I'm going to add the 0 and the 2. In the numerator, we just saw, what an interesting coincidence, I actually did not plan that. 13 plus negative 5 is 8. K to the 0 plus 2, 0 plus 2 is 2. Now I've got division. When I divide two things with the same base, their exponents subtract. So this becomes k to the power of 8 minus 2, which is k to the 6th. And finally, I've got e to the 8th over e to the negative 3rd. Well, that I can simplify. When I divide two things with the same base, we know that their exponents subtract. So this becomes e to the power of 8 minus negative 3 times e to the power of negative 2 minus 4, right? I do division, I subtract my exponents. From here, I have e to the power of 8 minus negative 3. Minus negative really means plus, so this is 8 plus 3, which is 11. And then I have e to the power of negative 2 minus 4. Negative 2 minus 4 is negative 6. From here, all I need to do, I am multiplying, so now my bases add. This becomes e to the power of 11 plus negative 6, and 11 plus negative 6 is positive 5. There we go. Let's keep it moving. Let's do some multiplication. 4h squared times negative 5h to the 4th. We'll do this one together, and then I'll set you loose on 2 and 3. I would encourage you to take 30 seconds, see if you can try number 1 before we move on. But I'm going to keep going. Number 1, 4h squared times negative 5h to the 4th. Again, my advice to you, make this look the way you want it to look. It can never hurt to break everything down and chunk it as much as possible. So first of all, I'm making the invisible visible. Let me make it really obvious that all of these are connected by multiplication. What chunks do you think I might want to create here and why? 10 seconds, pause the video, go. All right, we'll say that I'm dealing with this 4. I don't know how to multiply 4 by h squared, but I do know how to multiply 4 by negative 5. So I'm going to chunk it so that the 4 and the negative 5 are together, and the h squared and the h to the 4th are together, because I know how to multiply numbers, and I know how to multiply, in this case, my h's. What property did I just use, by the way? 5, 4, 3, 2, 1. Well, the property that tells me I can do multiplication in any order I want, this is the commutative property. For my first chunk now, I'm home free. Well, 4 times negative 5, that's equal to negative 20. And then I've got h squared times h to the 4th. That's h to the power of 2 plus 4, which is h to the power of 6. Negative 20h to the 6th is my final answer. For number 2, same idea. Let's chunk it. I've got 3 times g to the 8th times 7 times g. Once again, I want to create some chunks with the stuff that I know how to do. So I've got 3 times 7. I know how to do that. And then I've got g to the 8th times g. I know how to do that. Well, 3 times 7 gives me 21. And then g to the 8th times g. Remember, there's an invisible exponent of 1 here next to my g. G to the power of 8 times g to the power of 1 is equal to the power 8 plus 1. So I've got 21 to the power, or 21 times g to the power of 9. And last but not least, again, I've got some more variables here. So even though it's a little bit more complicated, the fundamental idea doesn't change. Let's create some chunks. So first of all, can't go wrong by showing too much work. Let me break this down using some multiplication. So I'm going to take each of these pieces, pull them apart, make the invisible visible. From here, I know how to multiply -4 and -6. Let me group those two together. M to the 5th, I know how to multiply by m squared. Let me put those two together. And then n to the 7th and n to the 4th, I'll pair those two up as well. -4 times -6, well, that gives me positive 24. M to the 5th times m squared, so I have m to the power of 5 plus 2. And then n to the 7th times n to the 4th, I have n to the power of 7 plus 4. 24. M to the power of 5 plus 2 is more simply m to the 7th. And n to the power of 7 plus 4 is n to the power of 11. There we go. Here's our final answer. Now that we've done some multiplication, what do you think is coming next? You might have guessed it. It's division. Let's try it. We'll do number 1 together, and then I'll set you loose on number 2 and 3. I would encourage you, pause the video, try and figure out number 1 by yourself first before we do it as a class. But now's my time to do number 1. -35 f to the 7th over 5 f to the 3rd. Again, my advice is to invite you to chunk this. I know how to divide 35 by 5. I know how to divide f to the 7th by f to the 3rd, so I'm going to write my chunks like this. First of all, I hope you can agree with me that if I write each of these fractions separately and join them by multiplication, first of all, pause the video, figure out if you agree that these two statements are the same thing. Do you agree if I multiplied the numerators and multiplied the denominators, I would get back to the original statement? Once you believe me that that's the case, let's simplify. Well, now I've got -35 divided by 5. That's -7. And I've got f to the 7th divided by f to the 3rd. Well, here I am dividing, so now my exponents subtract from each other. This would be 7 minus 3. So I've now got -7 times f to the power of 4. I can erase this invisible multiplication symbol. Let me write this as -7 f to the 4th. Cool! Now that you've seen this first one, try it out on your own with numbers 2 and 3. Go, go, go. And stop. Number 2. Again, I'm going to create some chunks. I'm going to pair the numbers together. So I'll create a fraction for my numbers, and I'll create a fraction for my q's. For my first fraction, -10 over -12, well, I have a negative divided by a negative, that's a positive. 10 over 12, I can simplify, divide both of them by 2 to get 5 over 6. And then I've got q to the 8th over q to the 11th. Well, here I'm dividing, so again, my powers subtract. This is q to the power of 8 minus 11. So I've now got 5 over 6 times q to the power of -3. Well, q to the power of -3, by our third law of exponents, that's 1 over q to the 3rd power. And now if I multiply my numerators, multiply my denominators, 5 times 1 is 5, and 6 times q to the 3rd is 6q to the 3rd. And finally here, I've got 18j to the 5th, k to the -2, over -24, j to the 7th, k to the 2nd. So again, let me create some chunks. 18 and -24, I know how to divide those. So let me also chunk my j's together, j to the 5th and j to the 7th. And then finally, let me also chunk my k's, k to the -2 and k to the +2. From here, 18 divided by negative 24. Well, I can simplify this. 18 and 24 are both divisible by 6. That leaves me with negative 3 over 4. I've got j to the 5th over j to the 7th. I'm going to subtract my exponents. This would become j to the power of 5 minus 7. Same thing with the k's. I subtract my exponents. This becomes k to the power of negative 2 minus 2. So here, I've got negative 3 over 4 times j to the power of negative 2 times k to the power of negative 4. From here, I've got negative 3/4 times j to the power of negative 2 is 1 over j squared. K to the power of negative 4 is 1 over k to the 4th. Last but not least, we'll multiply across all of our numerators. I've got negative 3 times 1, so that's negative 3. And in the denominators, I've got 4 times j squared times k to the 4th. That's 4j squared k to the 4th.